Hi everyone, good evening. Am I audible to all of you? Can you please all respond in the chat? Can you all please say whether I'm audible properly? I hope I'm visible to you all, but I would also like to know whether I'm audible properly to you or not. So could you please respond in the chat, guys, and we would start the session. So let's see who all are there in the chat. So okay, we have Sujit, Arijit. We have Praveen, Prashant, Prem, Mohan. Good evening, guys. Good evening, everyone. Good evening. I all I see like yeah, you were there yesterday, even you are here today. That's great. That's great. Nice to see you all again on this session. Asmiya, Chakradha, Arushi, Mohan. Yeah. Okay. So guys, good evening and welcome again to the day two of system design. This would be our last day as it is only a 2 day program. So this is it, day two system design. I hope all of you have submitted your assignment questions. Okay, there were two questions, and I hope every one of you have submitted. Even if you have not submitted yet, you can still do it today. So I'll be giving one or two questions today. Okay, so you can actually directly submit all of those in a single document. That is also fine. Okay, but it would be better for me to review all those things if you segregate and put in the day one assignment as day one file, and put in the select day two in the form, and put day two assignment separate. It would be easier for me to segregate and see. Okay. uh, Avinav, I think you are in the wrong program. This is not an app sheet program. Rather, we are discussing here system design. Okay, so we are here for system design. We'll be discussing system design. So just a quick brush up, guys, of yesterday. So what we did yesterday is we discussed. We started with what exactly is system, what is design, exactly system design does. We understood functional and non-functional requirement. We then understood. We discuss a few component of a system while building. What are the components we need to take care of? That components we discussed. Then we discussed. Yeah, many things we discussed. What are the other things? Components we discussed. Then we discussed client server architecture and some other points also, like thick, thin client, 2 tier, 3 tier, entire client. We discussed load balancer, what is load balancer, what it does, and the strategies we discussed of load balancer. And we discussed, I think, CDN we discussed at the end. Okay, I have the list of topics that we did yesterday. I have like noted down the sequence. So yeah, that's what we had discussed. We discussed scaling, vertical and horizontal scaling. I hope, yeah, that is what we had discussed in the last class. So today I'll be discussing. I have listed on few more topics here. Okay, in my small diary, you can say. So that is what I will go for today. And yes, I have planned to go for a project. Some of you are also asking whether we can actually do a real live situation, and we can actually see where we can implement, how it is implemented. Yeah, I'm taking today, guys. I'll be doing this Uber system design. Not exactly, but yeah, somewhat we would cover that Uber thing, cab booking system will do, and you will have a good amount of insight of whatever we have discussed today. Okay, so I think we are all up here, and we can start this day two session. So I'll quickly go to the PPT where we were discussing yesterday, whatever. So I'll continue in the same PPT, and I'll again share it over the. I think you all have got the material of yesterday's session over community. If you have not checked anyone, please you can check the community group. The link is mentioned in the description of this video. So yeah, of course, after this session you check it and you will get the material of day one. Or even if you have not checked it, after this session I'll be putting a material, guys, the PPT. It would contain both day one and day two. Okay, so not to be worried. So let's start with this cache memory caching. We were discussing yesterday about caching, so let's quickly go to caching and we'll discuss. Okay, let me change the scene here. So we'll go to our class. Yep, so this is the thing which we were discussing: load balancer strategies, round robin we discussed, and also this load based strategy also we discussed, and we discussed CDN, the content delivery network. Okay, and we now know what CDN does actually. So it makes people available not people available, it makes the resources, the static resources available to all the people around the globe, right? So yeah, let's go to caching. So I'll just caching or cache and just say. So I think we had a simple discussion, a simple discussion on caching, that is um, yeah. So caching is used, basically we use caching for to reduce the load on the database, right? Between the database where we are actually fetching data from database, we put this cache between database, so that before actually trying to put a request, trying to put a load on the database, we actually search in the cache memory. Okay, if the data is found, then we'll like take it from cache and will not put a load or put a request on the database, right? So that reduces our load on the database. Also somewhat the latency is also reduced. Latency is also reduced because cache will store the uh, cache would be yeah, cache would store the recently used data for some temporary time or something. Okay, so that is what cache does. So two major points of cache, what it does, it reduces load on the databases. Also it improves the latency. Okay, it improves in the sense it decreases the latency, I would say, right? Raghavendra, no code has not started yet. Yes, it has not started. I think you might have got the mails and community posts have already been done. So there is actually a heavy rainfall at Mumbai. I think everyone knows that. Might have heard about from news. So that's why there is a power outage. So that session could not be done. But yes, we are up for system design. So we will continue, guys. There is no problem on system design. So we'll do it. Okay, we'll do continue our system design and we'll finish it up today. So caching. So there are various cache strategies, guys. Cache strategy in the sense, see, cache obviously would have a limited storage, right? So let's say some data we would store. Yeah, Abhimanyu, hi. Some data will store. Let's say some data is data 1 is stored, data 1. Then okay, data 2 is stored. Then data 3, fine. Okay. Then data 4. Let's say there are 4 data that can be stored in the cache memory. There is no more slot. Okay, so the next time a new data is, let's say, fetched, a new data is fetched. So what would be done? One more data would be fetched. So if there is a new data, so first it will search in the cache memory, right? Let's say I'm searching for data 5. I'm searching for data 5. So it will search in the cache memory. It will see that okay, there is no actually data here. Like there is no data 5 in the cache memory. So what cache will do? So cache will pick this data 5 and will try to store here in the cache. But the problem here is cache can store only 4 data here. So any one data it has to get rid of. It has to remove any one of these data 1, data 2, data 3, data 4. It will replace one of this data and store the data 5 because this is the thing now it is required. So there is something called temporal locality and spatial locality, guys. I don't want to get into those concepts right now in the cache, but just a quick information to all of you. So what happens is, it says if a data is being fetched, okay, there is a chance that in near future, very near future, it would be fetched again. Okay, so the data you are fetching now should be stored in the cache for the next time, right? So due to that reason, when data 5, a new data is fetched, that needs to be stored in the cache memory. Okay, but the thing is here, the cache is also limited, right? There will be some limitation on the memory storage. So already we have stored, there was 4 slots, let's say. So we have stored 4 data 1, data 2, data 3, data 4, and now I want to fetch data 5, which is not in the cache. It is a new data. So there would be one data that would be replaced by data 5. So which one is that data? Whether I will remove data 1 or data 2 or data 3 or data 4, which one I would replace with data 5? That is the question here. So that these are called eviction policies, or you can say case replacement policies. Okay, but normally we use this eviction policies. There are certain amount of number of eviction policies, guys. Okay, I have listed down a few which I'll be discussing. There are many actually lots of eviction policies are there. I have picked two here in my note, that is LRU and LFU. Okay, so LRU is nothing but least recently used, and LFU is least frequently used. Okay, these are the two very important and two commonly used strategies in cash eviction policies which I have picked actually. Okay, so without wasting much time, let's actually discuss what are these eviction strategies or eviction policies, you can say. Eviction policies, I hope the spellings are correct. Okay, right. CDN, Ninesh, you want me to repeat CDN? Okay, I'll just do in a short way. Fine, I'll do it. So see guys, CDN is nothing we are doing the class here in India. Okay, if someone from US would be trying to watch this session, obviously the latency would be more. That person would see the content like at a delayed time. Obviously, compared to you, that person would watch the content later at a delayed time. So obviously that would be a latency, because the data passes, the signal passes, has to travel so much distance, so obviously that would take time. Okay, so what happens, okay, live content we cannot do much about it, but what happens when we have this static resources? You go to website, let's say www.letsupgrade.in. Okay, if you go there, so there would be at least a logo, right, that needs to be downloaded. That would be maybe some 50 kb, let's say for example 50 or 100 kb. So that needs to be downloaded, so that will take some amount of time, like time to get downloaded. You are in India and the server is in India, so obviously it will take less time for you to like download it. But if a person from US is trying to open that website, so that same logo would take more time to get downloaded in his like browser or something. Okay, because simple latency, data has to pass from India to US. That would be like so much of distance, signal has to pass, it will take more time. So in order to improve this latency or decrease this latency, what we can do, options are two. We can set up servers in US also, maybe in Australia also, in Japan. Like Japan would be like closer to us, but anyway, the farther countries, you can say I'll set up servers in each of these areas. But that would be more costly, obviously expensive. We cannot set up so much of servers there. Okay, right. So what we will do is CDN actually comes into rescue for this purpose. CDN is content delivery network. It would set, like it says, your server be at the place wherever your server was, let it be there, let it be there in India. Okay, CDN networks, the servers, they would actually will have a number of servers in all this location, which will act as a storage of your static resources. So that, so in US we have a CDN, in Australia we have a CDN, maybe in other countries we have a CDN of our resource. So if a person trying to open a website, that static resources, is logos or images or text, those will be loaded instantly. Not instantly, yeah, it would be loaded faster. It doesn't have to request a server in India, rather it would just be fetching from the CDN those request, those resources. That's it. That is actually CDN. Okay, yeah, caching, see, caching is nothing but, I think I had told you yesterday. Anyway, I'll just do it again. Okay, so let's say this is the database, right? This is the database. So I have to fetch some data every time. Maybe this is the user. Okay, for user I would, something we had picked earlier. Yeah, maybe this is the user, right? User would try to fetch data from database, not directly though, maybe through server or something. Okay, that we have already discussed. I'm just trying to explain simply. So every time we are putting request on the database, we are putting load on the database. Okay, obviously the process would be slower compared to this. So what this cache will do is, cache will come between this database and the user, you can say. Actually, it would come by maybe a service or an application or something you can say, but yeah, for our purpose, I'm saying okay, there would be a cache memory here. Uh, okay, right? So before actually putting a request to database, the request should be put on this cache memory, right? The request should be put on the cache memory. If cache memory has that data would be sent back. That data would be sent back. If cache doesn't have, then it would the request would be put to the database finally. Okay, that would be put on the database. The request would be from the database. Obviously it would take more time, obviously, when we are going for database. So we are actually, when we don't have cache memory, all the requests are going to database. So database, the load on the database is more, first of all. Second, the latency would be more. Okay, latency means the time taken to get the data, process the data or something, process the request. Obviously from database, if you want to fetch the data, it will take more time, but cache memory is a faster operation actually compared to your database. So cache comes in between your before database. It will try to fetch the data from cache memory. If cache has it, will get data faster and will also reduce the load on the database. But let's say your cache do not have that data, so it will obviously go back to the database and fetch the data. There are various mechanisms actually. Okay, I'll try to discuss them in briefly. Okay, so this is what cache does. There are many cache you can use. Memcache is there, Redis is there. Redis is popularly used, guys. Redis. So all these components or all these features actually are provided by any service provider, guys. You go for AWS, you go for GCP. Okay, so all your servers and all these machines, all this component cache, database, so CDNs and all these all would be provided by your cloud actually provider. You don't have to worry about that. So while you are setting up your environment in the cloud provider, so you just have to like check this thing, and if you want to take it or not, that is what you have to go for. These are all, you can say, all these things are contained in the cloud service provider as an infrastructure. That is what we are paying for, right? If you increase more number of components or more number of instances, then obviously you'll be paying more. So that's a like a trade-off you have to make, right? Okay, so let's talk about this cache memory. We were talking about this eviction policies, right? Eviction policies. So right now we say the cache has only 4 slots. So it contain, right now it is containing data 1, data 2, data 3 and data 4. But the next request is for data 5. Obviously the cache doesn't contain. So what it will do, obviously from the database the data will be fetched. But this copy, the data file, copy of this data file would also be stored in cache memory. Okay, would also be stored in cache memory. Obviously, because there is a chance that we would need data file again sooner. So if we store in cache memory, then we can get it faster. Also, it will reduce load on the database. The simple concept of temporal locality. If some data you are fetching, there is a chance that you would again need it in your future. Okay, but we see that cache already had this data, like had its capacity filled, so it has to replace anyone, data 1 or data 2 or data 3 or data 4, anyone it has to replace. Which one it would replace? That is why we are studying eviction policies. Based on these eviction policies, we would replace any one of them. So I'll be picking these two, LRU and LFU, guys. There are many eviction policies, but to cut it short and to keep it simple, I'll discuss these two eviction policies, that is LRU and LFU. LRU and LFU, least recently used, least frequently used. Okay, so how does cache mechanism comes to know when new data is present in DB and needs to fetch from the DB, not to serve from cache itself when new data present? So there's actually what happens is we go for cache first. If the data is not found in cache, then it goes to database. The request is sent to database actually. Okay. So when it is not found, we say it has one is cache hit, one is cache miss. Hit means if the data is found in the cache, that is cache hit. When you go for if the data is not found in the cache, that is known as cache miss. Okay, so when you come across cache miss, So data would be fetched from database, one more copy would also be stored in cache memory, and yeah, so fine. If the next time the same data is fetched, now it would be cache hit. Got it? Understood? Obviously it would increase your system complexity, but sometimes it would help you. So it would use some internal mechanism, Rohan, and it would like update the cache memory. Let's not get into all the internal detail. Maybe some coding, some code we will write or something. That is all. Those are low level design. We are talking about high level design. We are talking about system design. So we will not talk about. Let's not get into those stuff. How cache is refreshed, updated, and all. Okay, just know that when data is not found, the data is fetched from database and the cache is like updated with a new. So now we are discussing which one to replace. If the cache was already full and we got a new data to store in the cache, which data needs to be replaced? How, like how to choose which one to remove? So we are talking about here LRU and LFU, which are the like two of the popular eviction policies which we are discussing. So yeah, let's go for a new slide. Here I'll be talking about LRU. Actually, I'll be talking about both LRU and LFU. So list recently used, guys. Let's say I'm fetching some data. I needed first data 1, then I go for data 2, then I fetch data 5, then I go for data 3, then I go for maybe again D1, and then I go for D5. Okay, then I again go for, let's say, data 1 again, let's say 1. Yeah, right. So these are the thing which I am doing right now. So this is the data I'm fetching. First data 1, then again data 2, then again then data 5, then data 3, then data 1, data 5, and data 1. Okay, so let's make this maybe a table would work better. Like I just need 4 slot. That's fine. I need to be here. So when data 1 is fetched, so data 1 will be stored in the slot, in the cache slot. There are 4 cache slots, let's say. Okay, so D1 is stored first, then D2 is stored, then D5 is fetched. Okay, then let's say D3 is stored. Fine, right? My bad. Yeah, so D3 is stored. Now we are again going for D1. So D1 is there, so there is no issue. There is no issue, right? Then again D5 is fetched, so D5 is fine. D5 is already there in the cache memory, so no issue. Again D1 is fetched, so D1 is already present in the cache memory, so there is no issue. Let's say the next time I am fetching something called D4, which is not in the cache. Obviously we'll come across cache miss. There is no D4, that would be fetched from the database. When we are fetching a new data, that also need to be stored in the cache memory. Cache needs to be updated now, so someone we have to replace here, either D1 or D2 or D5 or D3, right? Which one we would replace? So LRU says the one which is least recently used, recently which you have not used, to delete that. Okay, right? Okay, so maybe I'd put a counter actually here. Maybe D1, let's say how many times it has been called, not exactly how many times, which is recently called. So you see here D1 was recently called, so fine, we don't have to delete it. D5 was recently called, okay. D1 was again called, fine. D3 was called, okay. So then D5. Which one is the least recently used? We have D1, D2, D5 and D3. D1 first, the very recently, which one was called? Very recently D1, after that D5, after that D1, okay, fine, then D3, right, then D2. So D2 is the least recently used. Recently we have not used D2. D2 was used long ago. So then we can remove D2. That's what. So we would remove here D2, and instead of that I would just store D4, the new data. Right. I hope you understood, guys. I hope you understood this one. Okay, so recently which is not used, that one we would replace with the new data. That's what we are doing here. Clear everyone or not? Is it clear everyone? Okay, now we'll just replace one, we don't have to replace two. We'll just replace one, like we'll just replace d2, that's it. Okay, so you can for easy purpose you can just go backward, guys. You can go backward and see which is the least recently used. Okay, the one which would come in like at last, that we have to remove. D1, then D5, fine. Okay, then D3, then D5, then D2. So D2 was used long ago. Okay, d2 was used long ago, so we would remove d2. There is a very less chance that we would need d2 again, because it was used long ago, maybe not very long ago, maybe just some time they would put, and it would replace d2 there. This is what LRU says. Okay, this is what LRU says, least recently used. So same thing I'll be covering, like mostly same, but yeah, it's kind of different, bit different from LRU is LFU, least frequently used. Least frequently used. So it itself says there is something related to frequency. Frequency. Okay. So it will see. Okay. Now we had this many requests. How many times D1 is called? D1 is called as D, three times. Okay. How many times D4 is called here? D4. Okay. No, we had here D2, right? Okay. Before calling D4, guys, I'm saying D2 is called once. Then what is D5? D5 called how many times? Two times. And D3 is also called once. Okay. I'll just do one thing here. Maybe I'll just add here d2 just to keep it simple, guys. There is it can actually go for any other when it is a tie, then it would maybe go for some other algorithm, like in addition to this some other competition will be done and it would remove something, but I don't want to get into those stuff and I want to keep it simple. So let's say d2 is actually called twice, d1 is used thrice, d2 is used twice, d5 is used twice, and d3 is used only once. Okay, so which is very least frequently used? D3 is the one which is actually least frequently used. Okay, only once. D3 is used only once, but D1 is used 3, D2 is used 2, and D5 is accessed 2 times, twice. Okay, so here D3 is the least frequently used. That's what we need to remove. Okay, so we'll remove this d3 here. Yeah, we'll remove this d3 here, and we would store d4 in this slot if we are fetching d4 next time. I hope you understood, guys, this one, both LRU and LFU. Not very difficult, but yeah, I think you understood this. Everyone, please confirm, please confirm, did you understood? Sorry, did you understand this? LRU and LFO. These are some of the eviction policies. Then there are other also. Okay, like someone was mentioning FIFO and all. Yes, you can also go for that. Many. There are a lot of eviction policies. Is it clear, guys? Everyone, please mention in the chat. Please mention in the chat. Is it clear to everyone? Everyone. I would proceed to the next one. I have series of stuffs to discuss actually. Okay, right? Yeah, a lot of stuff, protocols. Then we'll be covering a project on Uber. Okay, also I have listed down something called queues, that are not the queue which we have discussed in data structure and algorithm, but yeah, message queues we'll be discussing here, right? Okay, that's great, that's great. Okay, fine, that's great. So the next topic here would be in the CAS itself. You can say strategies, actually the accessing strategies or the right strategies, those kind of, these are eviction policies or eviction strategies which we discussed, guys. Now the accessing strategies which I have listed down few of this, few of this caching strategy I have listed down. The how caching is done, what are the different strategies we have used. Okay, so caching strategy. I think this I should have covered this before I talked about the eviction policies. But I think anyway, no issue. We can still figure it out. We can still link it up. Caching strategies. So one is we have read through. We have cache aside. We have read through. We have write through. We have write behind. Okay. So these are the four caching strategies majorly. So one is read through. Okay, one is cache aside. Oh, my bad. Cache aside, we have read through. Okay, we have write through, and we have write behind. Write behind. Right, it's not a rocket science. So basically, you just have to um, search on this term and have to submit as an assignment. So this would be your first assignment for this session. Okay, I'll be giving one more assignment. So this would be your first assignment for this session, guys. You just have to do a bit of research on this caching strategies. One is cache aside, and there is read through. One is write through, write behind. Okay, it's very easy. Nothing like as of rocket science. You can just see it and write down. Okay, right. So yeah, fine. So I'll just give you one this cache aside, let's say I would explain, and the rest of the three you can have a research. So what happens in this cache aside is your system will have access to both access to both cache and your database or memory database, let's say. Okay, both. It will have access to both cache and database. Okay, if I try to okay, let's do it. It will take some time, but I think it's fine. The system, let's say this is a system, right? And also I need some, this is a cache. Then I have database. Database, right? So this is your system. Do you need me to write something on it? Maybe service, some service. Okay, and this is your cache, let's say. Okay, and this is your database, DB. I'll just write your DB. Okay, right. So okay, now see this. So this service will have access to cache directly. Also, it will have access to the DB. Bad. Right? So it has direct access. Obviously, this cache memory will have some access. It will also have access to the DB. Fine, that is understood, I think, because otherwise, how cache would get updated and all those stuff. So the service will have direct access to both cache and database actually in cache aside. Okay, so it will first search in cache memory. If cache doesn't have that data within it, so service will directly request database. This is cache aside. Okay, there is other ways also like read through or something. Yeah, read through we have. So in read through, what would happen is service won't have direct access to database. Okay, it has to go through the cache memory actually. It will request cache. If cache has the data, it will return. If cache do not have the data, then cache will request database. not the service will directly request database. Cache will request database. First the data would be written into cache, then cache will return the data to service. That is read through. You can search the other two, write through and write behind. They're all simple, guys. It will not be very difficult after I have explained this cache aside and read through, somewhat around that. Okay, this cache aside and read through more of a read purpose. They are used for read purpose, and write through and write behind, they are more of a write purposely used. You can just have a research on this, but in the assignment you put all these four definitions, or maybe explain what is cache aside, what is read through, what is write through, and what is write behind. Okay, just do it. Next I want to go for the next topics, that is protocols. So but before that, I just want to make sure if you understood this caching thing, and eviction policies and caching strategies, case aside and read through. It's very simple, you can just go through it, guys. Okay, so next topic, yeah, protocols. I have the list of topics here. Protocols, I listed it down because so that I didn't want to miss out any topic, and I didn't want to go out of the sequence, so that like it would be easier for you to actually link up and understand. That's why I have actually listed down here. Okay, so yeah, is it clear, guys? This caching strategies and the eviction policies of cache, LRU, LFU. There are other strategies also. If you want, you can actually see it. Okay, you can fetch it from internet, obviously. And yeah, so this would be your assignment, casing strategies. You can just write the topic name, the casing strategies. You write cache aside, read through, write behind, and define it, and just submit it. If you want to like include a picture depiction like I have done here for cache aside, is also good. If you just define it, that is also good. The problem is the definition is you just copy paste from the internet and put it. Okay, that is not the way. You will not actually really understand it. If you put up a diagram, that would be better for me also, like to analyze. I don't have to go through the definition first of all, and it would be easier for you to also understand actually, yeah, this is what happens in this casing strategies. Okay, so do this. Next we would go for protocols, networks, to be very specific. Network protocols, network protocols. So what are the protocols you have heard about, guys? Can you all mention in the chat what are the different protocols you have actually heard about it? What are the protocols you have heard? Network protocols. Let's see. Mention quickly, guys, in the chat. What are the different protocols you have heard about? Network protocols. Okay. When I say network protocols, we use them while we are accessing internet. Yeah, HTTP. Yes, HTTP. Okay, fine. That is a like commonly you can say very popular protocol. Very common. Like if you are browsing anything, we are accessing that. If you are giving a request to the internet, then it is HTTP, right? So it's basically request response protocol, HTTP. FTP is also a protocol, yes, file transfer protocol. Okay. Uh, yes, Deepak, TCP. I was expecting someone would say this. TCP, yes, TCP, transmission control protocol, very popular and very commonly used protocol. TCP, one of the like very important protocol. TCP. SMTP, simple mail transfer protocol, yes. Telnet, okay, fine. Other protocols who can say? Let's see. FTP, someone has already told. Internet protocol, okay. Okay, there are other things. Let me also mention WebSocket. You can say is a protocol. We have the rest. I won't say exactly a protocol, but yes. Anyway, we can include it. gRPC is there, mostly used for system like this communication between different application. That is remote something control. Exactly, I don't remember right now. gRPC. Not sure why it is gRPC. It is actually RPC protocol. Okay, remote something exactly I am not able to get it. Some communication. Okay, remote procedure communication, I think. Yep, you can always research, you can always search over internet. RPC, yeah, we can do it right now. We can do it right now. What is RPC? RPC full form. What is RPC? The exact name, the technology name, gRPC implements RPC, guys. We can use it, but RPC is remote procedure call. Okay, remote procedure call. Yeah. So yeah, so that is also a protocol which is used for communication between different services or applications. UDP is there, yes, Wajid, yes. UDP is there, a protocol. Okay, that's nice. So these are some of the protocols. Even GraphQL, you can say GraphQL. You might have heard about GraphQL. That is also there. So there are lots of protocols here. So we the most commonly used protocol is TCP. Okay, right? TCP. So I want to draw here something. This is, let's say, the whole TCP. Okay, let's say this is the whole TCP. Inside it, we can actually go for. Oh my bad. I can go for this. Okay. Yeah, we'll just color with this would be your WebSocket. Okay. Then your, I'll draw one more block. Right. This you can say it is actually. So I would just put a different color. I want to color it differently. Okay, fine. Insert text box. Here it is HTTP. Let's say, can we not take this to top or something? Okay, on the left. Can we not take it to top? There might be some way. No, this is not. Anyway, okay, fine, no issue. I'll just fine. So yeah, so in HTTP, you can say there are other protocols which we use based on HTTP protocol. Okay, there would be other protocols which are based on HTTP protocol. I'll just color it with a different color. I think this is fine. Yeah. So inside it we have say what else we have? What else we have? We have REST. REST is not basically a protocol, but yes, it is heavily dependent on the HTTP actually. Okay. Text not visible. Which one? Please use black color for text. Okay, okay, fine. Black, black, and I hope it's fine now for everyone. So REST, you can go for what is that? gRPC. What is something? RPC. Just commonly you can say RPC. gRPC is actually the name of the technology, and we can have what is the other thing? GraphQL. So these are some of the technology, guys. REST, gRPC, GraphQL. So yeah, so these are all based on HTTP. This whole thing is TCP. Okay, this WebSocket. It may be WebSocket, or it may be HTTP, or it may be REST. It may be gRPC. It may be GraphQL. These are all actually based on TCP. These are built on actually TCP. So TCP is the most important protocol here, and all these protocols here, WebSocket, HTTP, REST, gRPC, GraphQL, these are all built on top of TCP, guys. Okay, understood this one or not? Understood, everyone? Screen is not clear. Asmia, can everyone confirm this, please? Is the screen not clear? Please, can anyone confirm? Video, yeah, yes. Thanks, Joshna. Yes, that might be the case. Asmia, you can check your video quality setting of the YouTube, whatever you are watching right now. Is it clear, guys? Did you understand this? So TCP is the main protocol, transmission control protocol. Okay, so WebSocket, HTTP, REST, gRPC, GraphQL, these are all based on TCP. If you see this REST, gRPC, GraphQL, these are based on HTTP. HTTP again is based on TCP. Okay, so this TCP is actually it is a transport layer protocol. If you are aware of the layers of the networks, okay, so there are two models which we follow. One is OSI model, one is TCP IP model. So I'm basically talking about the OSI model, guys. Transport layer, there is a transport layer in OSI model, there is also transport layer in TCP IP model. Okay, but majorly I'm focusing on transport OSI model. Okay, OSI model I'm focusing on. So TCP is a protocol which is used in transport layer protocol, and there are other layers also, guys. This HTTP and all, these are actually majorly used in application uh, layer session. You can say, okay, if you consider TCP IP model, there are actually this network layer, we have something. Okay, we have this transport layer, data layer, network layer, transport layer, and application layer, four layers. But in OSI model, the same things actually segregated into 7 layers. Okay, I exactly, if I remember correctly, it is physical layer, then data link layer, then network layer, then transport layer, then session layer, then presentation layer, then your application layer. Okay, application layer is something actually which we use. Okay, which we use. So maybe an application which you're using, maybe in this PowerPoint which I'm using, this is an application layer because I'm directly using it, I'm directly seeing it. Okay, so so browser, I'm directly using it. So HTTP majorly it is actually application layer protocol, you can say. Right, there are many protocol. Transport TCP is a protocol actually used in transport layer. End-to-end transmission is possible because of TCP. Okay, there is one more competitor of TCP. There is option actually. One is TCP and one is UDP. Right. Okay, I'll come to this WebSocket. Like, what is the difference between the WebSocket and this? Like, when we go for WebSocket and not exactly TCP. Okay, even if WebSocket is based on TCP, but we can use WebSocket differently, guys. Okay, right? Priyanka, there is no other way. Actually, I had shared a file, form basically. You have to upload it there. You just have to upload a document, either document or a PDF. The PDF is also a document. So you can PDF document you can upload, or maybe doc file you can upload. There should not be any issue on it. Just check the file size and the um, type of the file you are uploading. That's it. Okay. Yeah. Now coming to the another protocol, actually this is a competitor of TCP, that is UDP, guys. I think I'm not sure how many of you actually have heard about this UDP. If I remember it correctly, it stands for Unified Datagram Protocol. I hope it's correct. You can check it anyways. Unified Datagram Protocol, UDP. We can confirm it right now. No? That would be like, we are so used to use these terms UDP, TCP, so we don't normally remember this full form. Actually, let me check it once. Yeah, it is Sorry, guys, User Datagram Protocol, not Unified Datagram Protocol. Okay, my bad. Sorry. It is User Datagram Protocol. Okay, UDP. So what happens? How it is different? UDP. How UDP is different from TCP? Okay. How TCP works? How UDP works? Let me tell you. First, let me tell you about TCP, guys. Then we will talk about UDP. Then you will understand actually. So let's discuss TCP. So TCP, what happens here is, let's say everything is client server model, right? Client server. So I'll just write here sender and receiver. For example, I'll just use here sender and receiver. Let's see. I have a sender here. Say, okay. This is a sender. We have a sender, and then we have a receiver. Fine. Okay. We can go for a timeline here. This doesn't look straight. Fine. Okay. So let me just put the names. Otherwise, it will get it will be confused. Like you will be confused. Everyone will be confused. Let's write. This is sender, or you can say client. Obviously, sender is the client. It is requesting, and this is receiver. Receiver. I hope the spelling is correct. Receiver. I think for this color we need to change the font color to maybe white. Yeah. So we have sender and we have receiver. Okay. So in TCP, what happens is the sender will send a request, or maybe it will send something. Okay, it will send something to receiver. Okay, then receiver will acknowledge, yes, I have received your data, whatever you have sent me data, whatever message you have sent me, yes, I have received it. Okay, after receiving that confirmation, we call it as acknowledgement. So let me also write here acknowledgement. Actually this is acknowledgement. Actually, can we write here I think so, yes, right. Acknowledgement. If you have already covered like your fifth semester or something in your BTech, I think you already have come across this term acknowledgement. Okay, this is the data packet the sender is sending to the receiver. See guys, the data, whole bunch of data is not actually sent directly. The data would be what we say scrambled, or maybe divided into packets, small packets, and the packets would be sent one by one. So you can say that here we are actually sending a packet number one. This one, this is packet one. So I will write pkt1. Okay, so let's say you have some picture, you are sending an image. Okay, you are sending an image, maybe I'm uploading, you are trying to upload this assignment file, right? You are trying to upload an assignment file, so the whole assignment file is not getting uploaded directly. It is actually going part by part. It is divided actually into small packet, and each packet would be sent. So packet 1 would be sent, receiver would acknowledge, yes, I have received packet 1, send packet 2. So then second packet would be again sent. This is how TCP works. Okay, this is how TCP works. Got it, guys? Okay. So after it receives acknowledgement for the sent packet, it will send the next packet. Got it? Let's say here one of the packet could not reach the receiver. One of the packet could not reach the receiver. So let me just write it, not to confuse you. So this is the packet 2 which which the sender was trying to send, but it could not reach. It could not reach. How can we show it did not reach? Any particular okay. Can we have something here? Yes, we have something here. So I'll just use it. Okay. So it did not reach, guys. It could not reach it. Like I just made a cross mark there, so just to notify that okay, it did not reach the receiver. So obviously sender will not get the acknowledgement for packet 2 it has received or not. So what it will do, it will again resend. Okay, right? It will not receive acknowledgement for packet 2. So there will be certain timeout actually, maybe let's say 2 seconds. So it will wait for 2 seconds. If it did not get, if it does not get acknowledgement by 2 seconds, then it will resend the packet to again. So it's a slower process, guys. TCP actually, it's very reliable in the sense you will not lose any packet, and all the packet would be in order. Okay, you'll get ordered packet, and it is very reliable, but it is slower for the same reason, right? Okay. Sujit, yeah, you have to submit your assignment on the same form link which is given in the description of this video. That's what. Okay, fine, understood this. So TCP is slower, but it is very reliable. Okay, because packet won't be lost, and also you will get the packet in order, guys. The order in which it was sent, you will receive the same order. Okay, compared to TCP, if I go for UDP, same thing doesn't happen there. Okay, right. So what happens there is, if this is the sender, okay, I'll just put here, and I just want to copy it, and this is the receiver. Okay, I think I have spelled it wrong. Receiver. Okay. Now sender, if sender does not wait for the acknowledgement, actually it goes on send, like it goes on sending the data packets. That's it. It won't wait for the acknowledgement, or it won't wait for the uh, response from the receiver before sending the next packet. So it would go on send it would go on sending packets actually. So it would be obviously faster but less reliable. Asmiya, which one exactly you want me to explain again? Which one? Okay, so okay, I'll just do it. I think you were asking about TCP. So TCP, I think this is more of whatever I'm explaining. If I'm correct, I'm explaining there is something called when connection is established. There is some handshaking theorem and all. But let's say we'll not get into that part. I'm just saying here that, so here's the sender. Sender would receive the packet one. So receiver has to acknowledge it. ACK, acknowledgement packet, it will send. Okay, it would also acknowledge that yes, I have received packet one. You kindly receive. You kindly send the next packet, packet two. So TCP would send the packet two after getting acknowledgement for the previous packet. Okay, unless it gets acknowledgement for the previous packet, it won't send the next packet, guys. Okay, so here I have depicted packet 1 was sent to receiver, and receiver has given the acknowledgement. So what TCP, in TCP what happens, the next packet would be sent. Let's say packet 2 did not reach the receiver, did not reach, so obviously receiver will not return the acknowledgement for packet 2. So there will be something timeout or something, maybe 2 seconds. Let's, for example, it is not 2 seconds actually, it's very less, but for just simple number I've taken 2 seconds. So sender will wait for 2 seconds, and if it does not receive the acknowledgement for packet 2 within 2 seconds, it will send it again. It will understand, yes, the packet has been actually lost, maybe it is lost, that is why I have not yet received any acknowledgement for it. Let's resend it. So sender will resend it. So data won't be lost. It is very much reliable TCP, but process is slower because you are sending data, waiting for the response, and then sending the next data. So that's why it is slower. Okay. In comparison, UDP, actually the sender does not wait for response. It goes on sending the data. Fatafat, fatafat, fatafat. So it will just send the data. It doesn't care about whether it has actually received or not. It will go on actually send the data, send the data, send the data. So there is a chance that one of the data, some of the, not one of the data, some of the data would be missed out. There is that, yes, some of the data would be missed out, but it won't know actually, has like it won't know whether the data was not sent or not reached or something. It will go on sending the next packet, next data. This is UDP. It is faster, process is faster, but it is not actually too much of what is that, reliable. You cannot rely on UDP if you want consistent result. Okay, obviously the packet would be out of order and something. This is UDP, and this is how it is different from TCP. So the question is, where do we use UDP? If UDP is very fast but not reliable, do we actually want to lose some data? As I'm saying here, UDP, there is a chance of loss of data, and we want the receiver won't know about it. A receiver may know, but sender won't know about that the data has actually not reached the send receiver. Let me send it again. No, there is no way sender will know it. So is there any system where actually we can afford this UDP to be used? because there is a chance of data loss. Can we really afford data loss in any of the system, guys? Let's see. Let's see chat. I'll go to chat. Let's see what you are answering actually. I would like to hear from you. Can we afford loss of data in any of the system, guys? Or no? If yes, you are saying you have to give example. If no, it is fine. Like we'll say okay, TCP is the most commonly used and we use always TCP. That's it. Yeah. Respond guys in the chat. Respond. Are you all with me? Uh Understood. I'm just putting a poll here. Understood. TCP UDP. Maybe torrent uses it. Okay, let's see. Majid no, Prithvi no. Okay. Sometimes torrent video don't play in between. Okay. Torrent you download, right? From torrent, or I am not very sure. You can also. Okay. I'll give you. Let's say let's take a particular scenario. How many of you here are playing video games? How many of you are playing video games? I hope like most of you would be playing video games. I play video games. Even I live stream it sometimes. How many of you play video games? Can you name some game maybe you are playing? Maybe like no one plays games, video games. No one plays video games. Okay. Yeah. So just put in the chat, guys. Everyone, anyone plays video games, online video games not exactly something installed in your system and you play offline. I'm talking about online video games actually. With the multiplayer games, you might be playing with different friends and all. They're playing, right? Have you ever seen this thing? Your friend, okay, it's a multiplayer game, so your friend would be stuck at point of time, but the very next moment that person would be at a different place or something. Have you ever experienced this thing? Yeah, Valorant, yes, that's a popular game. It happens. Lag, we say there is a glitch or there is a lag from your side. The moment you were actually you were actually standing at this point and there was some lag, you were stuck there, and the very next moment you were actually standing in a different place. So what happened actually? You did not get some data packet. Okay, you did not get some data packet, but that won't affect. Would that affect your playing at that moment? Yeah, sometimes it might be annoying while you are killing some enemy there and you face glitch, yes, but most of the time I'm talking about data packet, very minute data packet, guys. Okay, real time in nanoseconds, maybe yeah, every nanosecond some millions of many of data packets are coming. Maybe sometime the data packet would get lost. Even live streaming this stream, whichever whatever I'm doing right now, some packets, some frames are actually getting dropped, but that won't affect you because very next moment you are going to get the next data packet and you would okay understand, yes, this is what it was doing. So maybe let's understand this way. Okay, maybe what should I do here? Okay, so maybe I would be moving my hand from here to here in live stream. Okay, so what happens is maybe while moving here after this point, you will find my next movement of hand would be here, and then continuously you will find it. So no issue, right? There is no issue on it. So you still understand, yes, the hand was actually moving from here to here. That is how the person was moving hand. Okay, so maybe in between the time, maybe there would be a glitch, maybe some data packet you are losing, and the very next time you are getting from here the hand and moving. This is your like UDP. This happens in UDP. So normally in this streaming kind of thing, game, online game, streaming software and all, UDP is used, guys, because the very next moment will anyway will get the next data, next frames. That won't affect much. Even you can say CPU, like how much our CPU is used, the processes signals. Okay, CPU. If there is a system where you are collecting how much your CPU is used, okay, the data would be sent, right? So it is okay. Some data would be missed because the very next moment you will get the next data, and you can say yes, yes, that is like this much the CPU has been used or something. Okay. So it won't affect much. In such kind of system, UDP you can go for, guys, because that time you need very faster data packet to arrive at you. You are not looking for reliability, rather you are looking for let the data like faster passing of the sending of the message, faster receipt of the message. Okay, there you go for UDP. TCP is used where you cannot afford losing of any data. Okay, if a very crucial or if you're doing very crucial let's say banking operation or something, you cannot afford actually losing data, you go for TCP, not UDP. I hope I'm very clear about this TCP and UDP and when they are used actually. Clear, guys? This is it clear? Is it clear? Is it clear? Is it clear? Please let me know in the chat. I'm looking at your chat right now. So can you please mention the chat? Did you understand what is TCP, how TCP works, how UDP works, and what use cases UDP is used and what use cases TCP is used? Please check your file type, Smritanjali. It should be either PDF or a document. I think many of you, I already have got some responses yesterday. Okay, so please check your file type, what you are uploading. It should be a PDF or document file. That's it. Okay. So yeah, it's clear, right, everyone? Everyone? Okay, fine. That's great. Okay, that's great. So we all of us understood TCP and UDP. I see some people have not understood. only 33 votes. Okay, how many people are there today? Let me check. We have more people, but very less response. Fine, I would take it as have understood already. That's why you have not responded. Fine. So TCP UDP, that's cover my list of protocols which I was planning to use. But yes, I would also like to discuss some this WebSocket and STTP, between STTP and WebSocket. What happens here? Okay, right. So see, guys, I'll just quickly finish up this WebSocket thing. Why it is used, when it is used actually. WebSocket. So WebSocket, it is actually a duplex protocol, duplex communication, or you can say two-way communication. It happens. Okay, two-way communication happens. Duplex. When I say it is a duplex, so I have something to discuss here. WebSocket and some. I will be discussing about this HTTP and WebSocket normally. So it is a duplex protocol. What do you mean by basically duplex protocol, guys? It means two-way communication is possible. Two-way communication is possible. Okay, right. How it helps this two-way communication? So what happens in other cases, or let me just tell you what WebSocket does is, okay, for that I think I need some shapes here to include. Oh, not that. Shapes. Yep. So this is, let's say, the client or maybe sender, you can say. Yeah, we'll go with sender receiver only. Sender and receiver thing which we are doing, right? So this is receiver. So what happens exactly when we are actually communicating between two entity? Maybe not sender receiver, you can say this is application 1 and application 2. Your wish. I'll just keep it simple with sender and receiver. Okay, right. So okay, better if I say application one and application two. Application one and application two. So they want to communicate with each other. They want to communicate with each other. So I'll just bring this timeline again. Okay, right. Fine. So what happens exactly? So first of all, the connection will be established with application one and application two. There would be a connection that will be established with a request. So application one is requesting some data, okay, with some would be requesting some data, and application two would be sending back the data. Okay, then the connection is closed. Normally happens. Normally it happens. If you don't use WebSocket, then this is what it will be happening. Okay, so you'll send some request. Okay, connection request, it will connect and you will request some data and it will send back the data and the connection is closed. Okay, but in WebSocket what would happen actually, guys, in WebSocket, the connection would be persistent for a longer period of time. So every time you don't have to establish the connection. Once the connection is done, it would persist for a longer time. Then the communication can take place. You ask, you receive, you ask, you receive. So commonly this WebSocket is used in chat applications. Okay, I'll just quickly give an understand make you understand this chat application what happens. You can think of WhatsApp, guys. Okay, you can think of WhatsApp here, chat application. So what happened, this we have sender and receiver, right? We have sender and receiver. So what I'll do is I'll just copy this stuff and I would just paste it here, but I don't need this. Deleting this. See, guys, and here I don't want to, I'll go back to sender and receiver. So we are talking about WhatsApp. So you are, let's say, the sender and your friend is a receiver. So what happens here, you will send a message, right? You want to send a message, so you will send it. Fine, the connection would be established and you can successfully send the message to your friend. Fine, then the connection will be closed. Let's say your friend want to reply, want to okay my like want to reply, yes, want to reply. So that time your friend is a sender and you become the receiver. Obviously, when you are sending message, you are sender and your friend is receiver. But when your friend is replying, the friend would be sender and you become the receiver, so that the role would get interchanged, right? Because we are talking about this two-way communication thing. So it is not necessary that when as soon as you send the message, your friend would see the message and will reply. Maybe your friend would be in a meeting, or maybe he's out with the family, or his friend or her friend. So it's not possible, right? Always keep you, when you send a message, your the receiver would read it and reply it at the same time. What happens, you send the message will be sent to the receiver and the connection will be closed, right? So how would you receive the message again? You have to constantly establish connection. You have to constantly ask whether there is a message, whether you have to constantly ask the server. Okay, maybe there would be a server here in between the receiver and sender. So it will constantly ask the server, is there any message for me, is any message. So it will constantly say no, no. So what you are doing, constantly you are trying to establish connection. Okay, establish connection, and every time you are getting no, there is no. Maybe you will maybe every 5 seconds, or maybe every 2 seconds, or maybe every second you are actually opening the chat and going to the receiver particular conversation. You are trying to establish connection with his or her server, and asking, is there any message for me, so if there is no message, you will just get a no, no, there is no message, so nothing will be updated, right? Okay, so there the connection is getting established again and again. Actually, connection is getting established again and again. Your You are sending something, connection is closed. Again, you establish connection, ask, is there something for me? Is there anything from me? And it says no, no, no. In WebSocket, this is what it doesn't happen. Okay, in WebSocket, what happens is connection is established. Once the connection established, let's say, obviously it will get a what is that, acknowledgement that yes, connection is established. So once the connection is established, then it would be a long term connection. Okay, it would be a long term connection. Your connection will not be closed. Maybe there will be some limit of time, maybe some 5 minutes or 1 minute. I'm not very sure about that. So whatever, however they have implemented it, the connection will be open. Okay, and if your friend within that time frame, within that timeout time, if a friend sends back a message, you will directly get it. There is no need of again establish the connection, so the process becomes faster. So that's why WebSocket is duplex protocol, two-way communication. Once the connection is established, connection would persist for a longer time and you can communicate, okay, both ways, right? So that is this is what is a WebSocket protocol. This is what your WebSocket protocol is used. Mostly this chat application and all, they use WebSocket because they have to like constantly send receive, send receive message. So instead of establishing connection again and again, connection would be established once. It would persist for longer time and they can communicate each other within that connection. This is WebSocket protocol. Okay. So I hope everyone understood WebSocket protocol and how it is used. Okay, so the next thing which I want to discuss is, just please confirm guys, first of all, did you understand WebSocket protocol? Because with that I'm done with the protocols. Okay, I want to go with a different topic, that is your queues. I want to just go into queues topic. It's not the queue which we have discussed in data structure and algorithm. Some of you might have attended my data structure and algorithm classes, but it's not that queue, but it is a different queue which I'll be just discussing. I'll pick up this example of Zomato. It's very popular right now, and we have also, if any one of you are into trading, then you might know that Zomato has also released this IPO. Okay, right. So we'll take example of Zomato actually for understanding this queues thing. I hope everyone understood this WebSocket, UDP, TCP, difference between them, all this stuff. Okay, queues. Let's understand this queues. Why is queue needed, and how it helps us, this queues. So let's take this example of Zomato. In Zomato, what you do guys, you open Zomato application. It will show you a list of restaurants to you. You pick any, you select any restaurant, you put order. Okay, and the same thing at the same time, maybe many people would be doing at the same restaurant. Let's say I'll pick Domino's. I'm ordering pizza. At the same time I'm ordering pizza from Domino's, maybe several other people would also be putting the request, ordering pizza from Domino's, right? So let's first consider a single person, single user. Let's say I am ordering a pizza from Domino's using Zomato app. Okay, so maybe you can go for pizza, maybe biryani. I love biryani. I'll go with biryani. Okay. So I want to bring in user here. How to bring user? I will use this one as user. This is user. Okay. So I'll just write something over it. This is the user or maybe customer. That is whatever you write. User. And there is some system, that is, this is, let's say, ordering system, service, ordering service. You are ordering biryani, right? So this is ordering ordering service. So there should be one service which would make you able to order something. Okay, right? And there would be something, one more service that is very important service, that is your payment service, right? Payment service is very important, right? If you don't pay, then how are they going to run the business? So they also have need to keep track of this payment service. Okay, so what happens is, when this user, when user puts a request, order something, I'm ordering piece biryani, right? So I'm ordering biryani on the ordering service here of Zomato, right? So they would, while I'm putting ordering service, they'll calculate how much is the bill and all, everything, that is fine. They would also put a request in the payment service that you need to pay this much amount. That would be handled by payment service. Maybe what Zomato is using, what payment service, some gateway it is using, right? Okay, anyway, there are many lot of payment gateways services, maybe CC Avenue, maybe Razorpay, maybe there are lots of payment services which we use this gateway, these gateways, CC Avenues, and this all this stuff. Anyway, so normally, if I am the only one user, guys, I'm ordering something biryani. It's very simple for the ordering service. It will take my order, compute, like calculate the bill, and it would request the payment service. Yes, this is the payment you have to make. Please please process this payment. Okay, so user has to pay that payment, and this payment service, it will give back this like a confirmation. Yes, the payment has been made. So ordering service would like proceed further and give you the food back. Delivery person will come back with it, and this is the whole thing happen. This will happen only like when you are only one user. Obviously, when you are ordering biryani from a shop, you cannot expect that we are the only user, we are actually the only customer who is actually ordering biryani at the same restaurant. Maybe the restaurant is very popular, and the restaurant maybe prepares very good biryani, so many people would be ordering at the same time. Okay, right? So in that case, what would happen? Maybe I'll just duplicate this. I'll just show this. What I'll do is I'll create many users, guys, many users, but I need to segregate them. Okay, I'll delete one of the user. This is too much of user. Like for my space, I'll just delete it. Okay, fine. Hello users. Maybe we can just take three, guys. Let's take three only. Keep it simple. So all of these users are actually putting requests at the same time. They need biryani. Obviously, dinner time or lunch time would be common, right? Like more or less common. So they are putting request at the same time. Ordering service. So when you are actually using a synchronous system or synchronous flow, if the flow is synchronous, here I am talking about something called synchronous flow of the process. If the process flow is synchronous, what will happen? See, ordering service is very fast. Okay, ordering service is very fast, so it will take up your order, and it will ask the payment service, it will forward the request to the payment service. You have to make so and so payment, and then the rest of the thing will be processed. But usually, guys, payment service is actually slow. Okay, payment service actually, it is slow actually, payment service. What would happen? Synchronous says, synchronous, what will happen? The entire process would run at a speed of your slowest component, slowest service. Okay, so payment service is slow. So and yes, it will wait for the response, that whether the payment is made or not. So the entire thing would be, the entire process would be slower. So what would happen is, if you are ordering first, once your order, like if your order is not completed, then the next user order cannot be taken up. Obviously this would annoy all the rest of the users. Let's say payment service is crashed at a point of time. For example, let's say at a point of time, for 5 minutes the payment service is crashed, for example. What would happen? Even this user is stuck, and the rest of the user is also stuck. Okay, also the payment service, let's say it can handle only 4 requests at a time, but there are 40 people ordering at the same time. It will take up, like, it will what it will do, it will request serve 4 people, then 4 people, then 4 people, then 4 people. So unless it gives a confirmation, the next process cannot proceed, right? So this is the like problem with synchronous flow of process, guys. Okay, so Zomato wants lots of order, but the payment service, if the payment service is not very good, like okay, if they follow the synchronous flow, then they cannot take up more orders. Obviously the customer, it would lose customers at the end. Okay, that's where these queues comes into picture, and they make the life easier. What queues will do, uh, okay, I should actually, I will just copy, duplicate here, yeah. So what queues will do, queues helps us in asynchronous, okay, asynchronous flow process. Okay, instead of directly giving the payment service all the request, what would happen is there would be a queue in between. How the queue look like? Actually it looks, you can put anything, but I would pick up this one. Let's say, yeah, this is a queue, for example. Now ordering service will not directly actually put request on the payment service directly, it would actually put on request on the queue. This is an actually queue, guys. Let me write it, queue, queue. Okay, so even if the payment service is able to handle 4 requests at a time, ordering service would be now able to take up 40 requests, and it will just add the request to the queue, and queue would actually distribute the request to this payment services. Okay, as I have already told in the previous class, in the last class, there would not be one single instance of payment service. Okay, there would be various instances of payment service actually, so it will distribute among them, this queue and all this would distribute among them, so where it has to be put, and okay, right. I'll just keep in this way, maybe I'll just send to back, yeah. So these are some bunch of some instances of payment service running on. So queue, this will act as a buffer, guys. Okay, this will actually act as a buffer, queue will act as a buffer. So even if 40 users come, even if 50 orders come, even if 100 orders come, so this ordering service will not wait for payment service confirmation, it will just push the request to the queue, and it will then again start taking up the new orders. So now the process is being faster. At least user are able to place the order. Why? The payment would be done later stage, but at least user are able to order. Okay, add add items to their list, and put the request order or something. Okay, payment may be slow, but they're actually have added their item, that we can wait, people can wait. Yes, we have ordered, we have selected, we have invested time by choosing what food we want to eat today. Okay, what food we want today. So payment service would actually then they can wait for the payment thing for some time. They may not wait for so long. Yes, there will be certain instances of payment service, so then queue would one, like it would distribute one by one those requests. Okay, Suresh has asked a very good question: what happens if payment gateway fails in this case too? In previous case, guys, what would happen is, if payment service would crash, then the entire data what ordering service had sent, those would be lost. Maybe the user has to repeat the whole process again, add order again, do all the thing, the bill would be calculated again. So the user had to start from the like very beginning. That is not very good for the user, right? That's not very good for the user. No, even I'll not like it, you will not like it. So when you introduce this queue before payment service, in this queue is buffer, guys. All the details will be stored in queue. Even if payment service fails or crashes at a point of time, the data, the requests are not lost, it is stored in queue. Queue act as a, it is similar to a database, you can say. Okay, so it has the data, it has all the requests stored in it, so the data is not lost. The next moment when payment service is up and running, it will take up the request from the queue and it will be processed. Okay, understood the work of queue, guys? Understood everyone what queue is doing here, how it is helping actually for asynchronous flow process, how it is handling so many of taking up so many orders actually. Okay, understood, clear, guys? Please respond in the chat. There are many queues. Okay, you might have heard about rabbit MQ. You might have heard about Kafka. Kafka is a queue. Okay, RabbitMQ is also a queue. They are used popularly. These are the queues. Okay. Yes. Um if you want to know more, I'll not get into this because I would like to go for our project, that is we'll design this Uber system. Okay, so there is something called, you can, if you want to look for it guys, you can, this queues, that basically two types of queues used, that is message queues and another is pub queues. Subscription. Okay, publisher and subscriber, sorry, publisher and subscriber queue, pub model and message queues. Okay, these have a different actually working principle. Every queue will have a consumer and producer. In this case, now, this case, ordering service is the producer and payment service is the consumer for this queue. Okay, payment service is consumer because it consumes data from the queue, and ordering service is the producer because it produces data to queue or request to the queue, and then queue gives the request to the payment services. So there will be always a consumer and producer. Consumer will not care about whether, sorry, a producer will not care about whether there is a consumer running or not. Okay, it will just go on sending the response and clear it, like maybe it will then take up next coming request. Okay, similarly this payment service, the consumer will not care about whether there is producer or not. It will just take the request from queue and will start processing. Okay, so this is your queue. You can if you want to know more, you can just search about this message queues and pub if I'm correct. This pub is Kafka is one of the pub queues, and if I remember it right, and this RabbitMQ is message queue. Okay, there is a small difference between message queue and pub queue. Okay, because this queue actually do not give you confirmation whether the payment has been done or not. If I talk about a normal queue, this message queue, it doesn't actually give you confirmation whether the payment has been done or not. But normally we would need, right? Okay, we will need to get the confirmation. Payment service, the bill service or the receipt service, they need to know whether the payment has been done or not. Okay, Kafka, this pub sub queue would be helpful in that case because it provides notification. It sends notification to other consumers, okay, or other services attached to it, that yes, the process has been done successfully, payment has been received. Okay, you can have a search on this. Okay, pub sub queue and message queue. Fine. Yeah, we are finally at the stage where we can discuss about this Uber system design, guys. Uber system design. But I hope everyone has understood this queue. Please confirm me. Please confirm me. Same, everyone. Have you understood queue? What is the use of queue? How it is helpful in this ordering system? At least we have taken up. Even this, you can. This was a small project to make you understand the work of queue, guys. We have taken up the case of Zomato actually. Okay, Zomato app. Okay, it's a small project, mini project, just to make you understand the simple use of queue, how how this queue is useful in ordering services in Zomato, right? So your next assignment would be to the exam to put examples of message queues and pub sub queue. Okay, what are the different message queues available? What are the different pub sub queues available? Okay, right? Just search about it and you check it, what message queue does, what pub sub queue does. You can just put it as an assignment. You can submit this. Right now, let's get to Uber system design. Just take a moment, guys, everyone, because we have covered a lot of, I know, a lot of concepts we have covered. So let's get back, like, come out, yeah, let's like gathering all those concepts, whatever we have learned. Now it's time we can actually apply here in this Uber system design. Okay, so I hope everyone is with me to start with this Uber system design? Yes, no, please mention in the chat. Are you excited for this Uber system design, guys? Okay, fine, everyone. Yes, Rohan says yes. What about others? Are you all guys excited for Uber system design? Uber system design. I will be asking a lot of questions to you. You have to answer, and gradually we'll be making project. See, guys, project here in system design not exactly mean will be writing code and developing a software. No, system design is all about the pre development stage. Okay, what we have to use, how we have to implement, what we should take, what we should not take. Okay, that's what system design is all about. So let's go with this system design of Uber. Fine, let's say yeah. So I'll just take up an example of Uber. Yeah, Uber we will go with. I let me just once check if I have not left out anything. I covered. Yep, I covered Q. Yes. Okay, fine. Hmm. Yeah, fine. So we have covered this stuff, lot of stuff. Now it's time we cover Uber system design now. Not patterns, not patterns. I'm not talking about design patterns. Those are again, design patterns is more of implementation part. Okay, how do you implement something? So there are several design patterns, mostly focused on OOPS, object-oriented programming, and we develop and you code it accordingly, following those design patterns. Okay, we'll be designing the system here, system component. Okay, your server, what queue you will use, what cache you will use, what database you will use, how it would be maintained, how it can be scalable. Okay, scalability, basically capacity estimation, what are the functional requirement, what are the non-functional requirement, right? So let's assume that we are in an interview, guys. Okay, let's say I'm your interviewer and I'm asking you, design a Uber, design the system for Uber. Okay, so the first and foremost question would be, or the first or foremost thing we need to think about would be the functional and non-functional requirement. First, you think about functional requirement. If you can get the functional requirement, then you can easily say what are the non-functional requirement, because non-functional requirement are actually dependent on functional requirement. According to functional requirement, non-functional requirement comes. So what happens? What happens in Uber app, cab booking app? You install Uber app, you open Uber app, it would show you the list of drivers around you, right? And you just book it. Driver would come, pick you up, and leave you at the destination. This is what, right? This is what happens in a Uber app. Am I correct? Install a Uber app, you open the app, it will show you a list of cabs or drivers around you. So you put your destination, you book a ride, so any one of the cab would come and pick you up and will take it to your destination. That's what happens. Am I correct, guys? Or anyone here does not agree with this thing? Yes, this is what happens in Uber. Okay, yes, no, yes, okay. So before actually designing the Uber app here, so we need to think about so many of actually other concept also. So you need to if I'm interviewer and I will just say just design Uber app, and I'll say, okay, this is the thing, like when you install an app, you go there, it will show you so many cabs, and yeah, it'll show many cabs. You book a ride, some driver would come to pick you up and will leave you there at your destination. That's what it is doing. But you have to also think about, okay, how this process would happen. Okay, how the driver would know about my request, how first of all the 10 drivers around me would be shown to me. Okay, how if we have 10 drivers in my locality near me, how one of the driver would get my request and will come to pick me up. Okay, those are the things which we have to actually think about it. Okay, so also if we talk about user perspective, now if I am the user, like, let's say I'm a user, in my perspective I don't want to I'm not worried about how the drivers are connected. I'm only worried it should show me the cabs. When I open app, it should show me the cabs around me. I'll put my destination, I'll book a ride. Someone should come, one driver should come and pick me up and take me to my destination. That's it. Okay. Driver is also a user, right, of your system or not. If you are a your Uber company, your Uber app, for Uber app, there are two users. Okay, right now here. So one is this customer or rider, you can say, who wants to actually go to a different uh, a location. Driver is also a user. Driver will get request like, yes, they are also, you are also paying them money, they are also like getting some services from you. There are two kinds of user here. One is this rider, who you can say the who creates demand, and the drivers who actually are suppliers, you can say. Okay, demand and supply thing basically. So it can be called as a marketplace where someone creates demand and someone supplies. Consumer producer, you can also say, but yeah, but this seems too much apt actually. Okay, demand supply, this whole game of demand and supply. Riders create demand, drivers supplies the service, right? So both are actually users of a system. So you have to think both ways, guys. You have to think here, if a rider, I'll use this term rider and driver. Don't think about that I'm a rider and a provider. So okay, so we are talking about a rider here, Uber rider, and there is a driver, and now we don't have a, yeah, there is also provider, that is Uber app. Okay, Uber app itself is a provider which provides the services to both this rider and that driver. Okay, so basically Uber is actually singing the song I'm a rider. No, I'm not Uber not sing a rider like I'm a rider. It is provider. And anyway, so coming to my point, so here I'll book a ride. I'm putting a request. There would be maybe 20 of drivers near about me. Okay, the question here, the question here you should ask, or maybe you would be thinking that how would the driver actually will accept the request and will come to pick you up, and how is that would happen. There are basically two options. Either we would just put the request to only one driver, which is who is actually at the closest distance from the rider, or we'll take a proximity and we would notify all those drivers. Any one of them would just accept the request, and whoever accepts first and will come to pick you up and pick you up. These are the two options. Okay, see guys, in a system design, as I already said, every person will come up with a different solution, and every yeah, every person will come up with a different solution, and it actually would change the perspective interviewer. You can ask actually here, which one should I go for? We should, so it depends on the company policy, what they have planned, what is their business logic. If the company interviewer says no, no, I will just like to you should actually constantly if you are saying something, if you are making some assumption, you should ask to the actually interviewer. So interviewer will come for give you confirmation. Yes, we what we'll do, we'll just request one driver that is present very closest. Okay, or maybe interview will say no, no, we'll just put request to all of the drivers at the proximity, so that any one of them will accept and come back. Yes, boss, exactly. Second option seems very effective, right? Because not always all the driver accept the request. If I just put request to one driver and the driver would not accept, then yeah, then obviously that will be a very bad experience for the rider. Okay, so we'll go with the second option, where we will send a request to a couple of maybe 10 drivers around a proximity, not more than that. I cannot, if 100 cabs are there in a proximity, I cannot show 100 cabs to the rider. Okay, even that is not very feasible, and that is not very practically, yeah, that's not very feasible, convenient. So we'll just show, let's say, 10 or 20 cabs around the close proximity. We'll send request to all those 10 or 20 drivers. Any one of them who actually accept the request first, first come first serve. So he would get the offer and the driver would come and pick you up. So we are coming on the same line here. So before we actually proceed to system design, this is what we need to know first of all, how the system actually will work. This is the working, this is the functional and non this is the functional requirement actually which we discussed right now. Okay, right? Maybe Rohan, you can actually, that you can decide, less than 3 kilometer, less than 5 kilometer, that depends on the thing. Okay, so same thing Zomato also shows you, right? Delivery, like possible deliveries less than 3 kilometer or maybe 5 kilometer, kind of that way. Swiggy gives 12 kilometer up to, kind of that way. So here, before getting into this designs, you need some numbers. What? Very important numbers. So you just have to ask your interviewer, guys, what would be the total number of, if you want to system design a system, you should know how many users would be using this system, right? If you don't estimate a number of users, then you cannot design the system. So what would be the total number of users? Okay, right? Maybe the interviewer would say there would be 10 million, total 10 million users, total 10 million users. Okay, I have taken the same thing. Or maybe, let's scale it up. There are many users, right, who are using this Uber app. Maybe 100 million users, let's pick it up. 100 million users, total number of users means you have you are a registered user of the Uber app, you have installed it, so 100 million. Active users, at a moment, how many active users would be there? Let's say it is 10 million. Okay, right? I have listed down a various number of actually thing which we should take care when we're discussing. So total number of users is 100 million. That's a huge number of users, and we have active users 10 million. But at any moment there will be 10 million active users. This is the assumption that interview has to, you have to ask. Interview would be, should be confirming, should be providing you this information. If you interview is not giving information, you should assume this and ask if this is, if I am going in the right way, if my assumption is correct. If the interviewer gives a green signal, then proceed further, right? Okay, so we can say in a month 10 times, 10 times is actually on a particular user is booking a ride. Okay, so 10 rides you can say a month is what a particular rider is actually booking. See, while you are going for system design, noting down this few this thing is very important. If you don't note it down, then there's a huge chance you will fail, like you will not actually create a good system design. Now this is fine, this is all about rider side. Okay, I think I should talk about this riders. This is rider side. Okay, these are riders, these are detail of riders. Then same thing will go for drivers. There will be number of drivers, right? Driver, okay, drivers. Right? Oh, my bad. Happened. Oh, okay. Anyway, I think I can bring it here. Oh, my bad. Mm-hmm. Fine. So this is drivers. So coming to this drivers, actually, so what would happen is drivers, how many drivers would be there? I'm just taking some rough numbers, guys. Total number of riders are, let's say, 100 million. Active users is let's say 10 million, and 10 rides, roughly a particular user is booking 10 rides per month. Okay, yeah, we'll also come to that, Suresh. Yeah, we'll also come to that. Don't worry about it. We'll come to that. There will be some peak movements always. We'll come to that peak movement. Let's first assume the numbers actually first. I have listed down some numbers. I have already assumed some numbers because I don't want to make it a very vague discussion. So I want to go at a very mhm. Okay, I want to go in a particular direction. So drivers, I have thought of maybe 1 million drivers are there. Okay, then I have, let's say, um, hmm, 500k. like 500,000. Is it total total number of drivers registered, okay, in Uber. On Uber, that is 1 million drivers are there, and this is actually active drivers at any point of time. Active drivers at any point of time is 500k, and there would be some shift hours. Okay, not a driver cannot go for 24 hours. Okay, so shift time, shift would be 6 hours per day, let's say per day 6 hours. Okay, right. So this is some information which you need to first track it down before going to design the system, right? You either have to ask the interview will give this information, or you will assume it. Okay, obviously when you are assuming, then you should be very realistic assumption there should be. Okay, don't say driver should be 500 million, or don't say there will be 5,000 drivers. No. Okay, that cannot be. We cannot run Uber system with 500 drivers, of course. Right. Okay. So now, here. So this is the information we have. These are the numbers I would say we have right now for the total drivers and riders. The next thing which I want to discuss will go. I have listed down already, guys. Many things here I have listed down. So first, let's design this drivers wala part. Let's discuss this, the driver side of design. Then we'll come to rider side of design. So drivers side of design, driver can say, okay, see what I'm basically trying to say, what we discuss in function requirement. When I open an app, it should show me, when I open an app, it should show me the nearby drivers. That means your system is collecting the location of the drivers. Okay, so that comes first. Your system is collecting address of drivers, or location of the geolocation, you can say location of the drivers, and that is being shown to the user. Say yes, this is cab is here, this cab is here, the location, right? That's why I'm talking about driver location first. So driver location is the first thing which I am talking about here. Then let us sort that driver location. Okay, so what would happen when I go for driver location? There would be a driver. So driver I would show as a vehicle, guys. Okay, yeah, GPS info, you can say Vasha. Basa, yeah. So I would just insert a car here, just to show that that is a cab. Okay, cab, or maybe you can say it is the driver. So driver I would represent as a car, and rider is a user. So let me search for car here. Just take a moment, guys. Which one do you prefer? Which one? Just say me, and I will pick that. Should we go for this yellow one, because it also, yellow is a color of taxis? If you want some other, we have a lot of options here. Lot of options here. Which one do you prefer? Say me. I'll pick that up. Can we go with this one, guys? Let's go with this one. I think it also looks like taxi for me. To me, it looks like taxi, but it is actually not. Okay, I'll just go with this one. Okay, it's downloading. Yeah, we got it. We got it. So what I'll do is I'll bit. Yes, it. Okay, fine. Fine. Okay. Drop it, and I'll just decrease the size of it. So this is my cab, Uber. Okay, right. So this is the driver. I need to get the location of the driver. So there should be a system there which would UDP data missing. Okay. Okay, fine. No, not at all. No, okay, gamer. Okay. No, I don't think the number of. Yeah, can you really think of a system that there would be the number of riders would be equal to the number of drivers? Oh, never. Okay, never. Can you think of a Zomato which will have the number of delivery person would be equal to the number of customers? Just answer this question and you have your answer. I think you have your the answer to this. Is this correct? Is this correct? Can a Zomato have the number of delivery person equal to the number of customers? No, right? It cannot be. It cannot be, never. So obviously the number of drivers cannot be equal to the number of riders. Number of riders would be always more than the number of drivers. Always, always it would be. Okay. So this is my driver location. So I need to fetch the driver location from here. So there will be something called driver location. This is the driver location. Let's say driver location service. You can say driver location service. Okay. So this driver, what it is doing right now is, so it has to send its location, right? Send its location. That's it. It has to send its location. Maybe not always. There should be some time. So what should be the time? That also we need to write here. Maybe every 5 second. Maybe every 5 second, driver is updating its location. Okay, right? Okay. So it is updating its location to the driver location service. There is a service running up, driver location service. So the driver updating its location every 5 second, because I have not I don't want to have every second or maybe five. You can also think of 1 second, but let's keep it as 5 second. Every 5 second the driver is refreshing or updating its new location that would be stored in this driver location service. So obviously if it is sending its location, there will be so many of drivers, right? I need to store their locations. So of course there would be a database coming up here which would store the locations of the driver. There will be a database where I can store the locations. So this driver location service will fetch the data from the driver, and it would actually store the data in the database. So let me write this as db, the db. Okay, right? Now we have to think this communication between this driver and driver location service, what kind of protocol we would use. Okay, there are various options actually, starting from various options. You can say we can use we have option for grpc, we have this GraphQL, we have this REST, we have WebSocket, we have UDP. Okay, so which one we should go for? Okay, this GraphQL and RPC, they do not work well with the mobile application. So those are striked off. They are not good option actually. Okay, right? Wait a minute. It's not working for me. Yeah, no, it's working. Fine. Yeah. So this REST, no, sorry, grpc and this GraphQL do not work well with the mobile application, so will not go with the grpc and GraphQL. Just track it off. Then we have left out REST API, we have, sorry, REST, we have WebSocket, we have UDP. Even will not go with the REST here, guys, because it's just what this driver does. Driver is just updating, sending just its location. Okay, what is location? Longitude, latitude. Okay, geolocation. So we can also, I'll just say x and y coordinate here. You can just say x and y coordinate. So it is actually giving back an information, x and y coordinate or longitude, latitude information. This is what it is sending over this connection to driver location service, which would be stored in the database by the driver location service. So guys, see, what would you think? We here WebSocket and UDP are there. What UDP does? UDP gives me like very fast information, but there is a chance of loss of information. But driver, let's say, is a location. If I like lose a data, if I lose information at a particular instance of time, the very next moment I'll get its data. So obviously, if I consider nanosecond, how much the driver would move, how much the cab would move, well, like it mostly it would be in the same place. So anyway, I'll be getting the next data very soon. I can go with UDP. UDP, I think UDP seems to be very apt for this case, right? Okay, UDP seems to be very apt for this case, because we actually don't need uh, uh, like we don't need a reliable system right now here. Okay, we can fetch the data, the location of the Uber, this driver, every nanosecond, every moment it would send again. So if I lose any data, I can get its position with the very next moment. Okay, UDP can use, but I'll not take UDP, guys. I'll take WebSocket here, because it would help us in a later moment when we go on further in this discussion. So it would help us. So I would go with the WebSocket. Okay, so every 5 seconds it is updating its location, and the protocol I'm using is WebSocket and not UDP. WebSocket, UDP seems to be very apt here, but UDP is one way, guys. UDP just sends a data and doesn't wait for responses and all. But WebSocket is a duplex protocol. Two-way communication can happen. Later, while we develop this entire process, entire system, we would need actually we would need two-way communication here. That's why I picked WebSocket actually. Okay, right? So I hope you understood this driver location part. I have some other things also to discuss, why we have taken WebSocket. So every 5 second driver would be updating the data to this driver location service. Okay, that would be again stored in the database, and it would be sending the longitude and latitude position. Okay, I hope it's clear up to this. Now we have to do some mathematics here, calculation. We have to do some calculation. What I'll do is, this entire thing I would take up. I'll just store it here, because I want to write down something here. So insert text box. I want to write some, I have to do some calculation, guys. What kind of calculation here? We have discussed that there would be 500 um, 500,000 drivers always. Okay, I don't need the total number of drivers at a moment. How many active drivers at the moment? Because that many requests. See, what we are doing here is, uh, at a moment, the active driver would only put request, or put request. Okay, if 500k or 500,000 drivers are present at a moment, are active, so only those driver would put request or would put load on your system, not the rest of the driver. They are offline anyway. Okay, so we are focusing on this 500k drivers or 500,000 drivers. They're putting request, and we average shift we have taken as 6 hours. I have written down some numbers there already, because we don't want to fluctuate much and we want to go in a particular direction. So that's why. Yeah, so average shift is 6 hours. If average shift is 6 hours a day, if it is, then in a day there would be total, how many shift? Total 4 shifts, right? Because Uber is claiming that it is giving 24-hour service. At any point of time you want to go anywhere, I would get you a ride. Okay, but one driver is doing 6 hours of duty, or maybe 6 hours of shift. So obviously there will be total 4 shift in a day. In a 24 hour, there will be 6 for the 24. So 24 hours, in 24 hours we would have 4 shift total. Okay, right. Next, what is the next thing we have to think about? Okay, if active drivers are 500k, or 500,000 drivers are active drivers in total, in a day, you can say. So how many drivers would be there at a particular moment on an average? In total 4 shift in a day, we have 500k active drivers. Okay, you can say here it is active drivers. That means on an average how many active drivers would be at a moment. It's nothing but 500k divided by 4, that is equal to 125k drivers every moment. Active drivers, you can say active drivers, active drivers any moment, at any moment on an average. Okay, 125k, fine. Now yeah, we have 125k active drivers at any moment, and each driver is actually updating its location every 5 seconds, right? Okay, if there are 125k drivers, okay, then if I say that if they update their location every second, then there would be 125k requests per second. But here we have to discuss or assume that every 5 seconds they are updating the request. That means 125k divided by 5, oh, not this, 25k divided by 5, that is 25k request per second. Request per second. Like they're updating their position. Okay, so if there are 25k active drivers at any moment, in total per second 25k requests are being sent to this service, this system, driver location service. Am I correct, guys? Up to this, understood up to this? And I'll then come to this point. Someone was asking about what about this peak moment, what about this peak moment. I'll come to that point, but up to this, is it clear? Understood how it is 25k requests per second? See, per second is what we need to understand, guys. Per second, how many requests, and how can we handle? Okay, that's what we need to understand here. Yes, everyone understood 25k request per second. Per second, we are getting 25,000 requests from the drivers. Leave the rider part. We are talking about drivers only right now. And drivers number was less, guys, compared to the riders. Okay. Yeah, fine. Anyway, so now, yeah, so we have 25k requests per second. Now, what about peak moment? At peaks, what would happen? So this might get double directly. Yeah, I'll just go with this into 2. So 25 into 2, 25k. The request might get double. The number of drivers may get, active drivers may get double. So at peak I may get 50k requests per second. You may say that it might be also 4 times, it might be also 5 times, it might be also 10 times, but don't make it very vague. Go for some absolute numbers. At peak you can consider either 2 times or 4 times or maybe 10 times. But if you go for 4 times here, or maybe if you go for 10 times, that would be very huge, guys. That number of requests we don't get. Okay, even if you go for 4, then it would be 1 million requests per second. That won't happen. 1 million is the total number of drivers registered. So yeah, we can go for this peak, 50k requests per second. So we have to think about how we can actually handle 50k request per second. Okay, that is the bigger deal here. You take any database, guys. That means the driver location service actually fetching 50k locations, 50k updates per second, and it has to write in the database at peak. Obviously we are designing system, so we have to design it for the peak scalability. Can 50k request, can 50k writes can it be done? Can 50k writes be done on a database? The answer is no. No database can handle 50k request per second. Okay, we normally assume that 55k request per second is the maximum. Yeah, there are some databases which can go for more than that, but let's keep it very simple, let's keep it very straight. Let's assume that 5k requests per second is the database can handle here. Okay, that's what we need to say. There are some other database which can handle more number of requests. Maybe you will say, okay, I'll go for a very big database, too much of capacity database. But if you go for database with higher capacity, also you have to pay more money. Okay, so who is going to pay the money? Company will not pay so much money. If you say this solution to the interviewer will say, would you give me money to pay to the cloud provider, the infrastructure provider, to have this much database of high capacity, to have a database of so much capacity? That's not the solution. We have to come across some other way. Okay, so here I want to discuss something with this. I want to introduce you all something called database sharding, DB database sharding, guys. So what is this sharding? Okay, it's basically, you can say, we are dividing the database. Instead of storing all the data into a single database, we will be having a number of database. Okay, we'll be having a number of database. So and we would actually map them. Okay, so the common mapping, if you think about a common mapping, if you think about Uber, common mapping or common sharding way would be country based sharding. What is this country based sharding for Uber? What is country based sharding? So it's nothing but it's basically, I know, guys, I have taken some more time, extra time, but please be here. I'll just complete this driver part. Our project contains only this driver part. I'll not go to the user part, rider part, guys, because if I go to that part, then it would like shoot up maybe at 10 to 10 p.m. or maybe after that. I don't want to shoot up that amount of time. You might not be with me for that amount of time. It would be overload. Okay, yeah, then we will need some load balancer for our mind. Okay, so country based sharding, what is this? Country based sharding is nothing but we would go for our database. We will shard the databases. Insert shapes, this one. Yeah, so we would shard the databases, maybe this. So we have here how many databases? 1, 2, 3, 4, 5 databases. So country-based sharding, I'm just talking about the no, not load balancer. This is not load balancer. This is actually sharding. You are dividing databases actually. Okay, you are keeping a number of databases with you. Country-based sharding is, so for each country there would be a database, designated database. Let's say this is for India, and I'm talking about taking into concern considering Uber app. Okay, maybe for some other project, some other thing, you can go for like other ways of sharding. Here I'm talking about Uber app, so I'm taking country based sharding. Okay, right? So here what would happen is India, so all the records, all the data of the users in India would be stored in this database. Okay, for India there is a designated database. Then we have let's say USA, a database. Then we have, let's say, China, another database. Okay, then we have, let's say, Australia, another database. And let's say we have here UK, another database. So for 5 countries, maybe it can go for the number of countries, it would go for the databases. Maybe we have some, let's say we have 300 countries, so there will be 300 shards of this databases. Any user registered from India, his or her data would be stored in India. This database is designated for India, and so on, for like similarly for all other cases of countries. But the problem here is, what would happen in this country based sharding is, there would be no uniform distribution of data. There would be no uniform distribution of data. Like for example, we know the number of people, population is more in India and China. Okay, so obviously number of users in India and China would be more compared to US, Australia, UK. That means what we are doing, we are actually consuming, we are overpopulating India and China database, but USA, Australia, UK would be maybe very less, few data would be stored and the database would be empty maybe. So there is no uniform distribution of data here. So country based sharding is not a good option in our case. Okay, let's say in India there are so many users, lots of users. So India is now become a hotspot, that we call it as a hotspot. So India is hotspot, and rest all the country maybe very less users would be there right now. So they will, very few memory space would be occupied in those databases. So no uniform distribution of data is happen is done in country based sharding. That's why we go for the other ways of sharding, guys. What are the other ways of sharding? Okay, there are many ways of sharding. I will talk about here. For uniform distribution of data, so that the data are uniformly distributed on all these databases, and there would be no load on a particular database. It should not happen that one particular database is having so much of load but other databases having very less number of load. We should uniformly distribute them. Okay, that's what we are doing here. So the next thing is, what we can do is we can go for mapping some custom areas as charts, database charts. Okay, so there is no country based shading anymore. Okay, there is no country based shading anymore. So what we'll do is we'll take up the entire world, entire globe, and we'll think of that. We'll think of some custom areas. Maybe, okay, one area I will think of. Okay, it is a triangle. Okay, whatever area comes within this triangle, I'll put in one shard number one. Let's say. Okay, I think I should keep with this. Keep this. Yeah, I should keep this. I will just, what I'll do is I'll just drag it down, drag them down. Fine. Yeah. So I would, what I'll do is I'll think of, maybe I should go with, first, this is the earth, let's say the entire globe. Okay, I've just taken up something, don't judge me on that. Yeah, this is our earth, let's say entire earth. So what I'll do is I'll take up custom shapes, guys. Okay, so I'll put shapes. So I'll put this quadrilateral here. Okay, let's say I'll put this quadrilateral here, and I'll put this, maybe this triangle here. Okay, maybe I'll put this triangle here. So what I'll do, I'll take up this, like this, I'll pick up so many custom shapes and I'll try to cover this entire sphere, entire earth. Okay, right? So likewise, so what should be there is, there should be some mechanism which would map a custom area to our particular shard. So now there is no country based sharding. Maybe this is shard number 1, this is shard number 2, and this is shard number 3, and this is shard number 4, and this is shard number, let's say 5. Okay, right? So there would be some service which would actually map this custom locations to the shard, respective shard. So each shard would be actually representing each area here. The size of the custom area would be different. It may be as large as a country, or it may be as small as a city or town. Okay, not town, normally city. Okay, so there should be some service which would actually map down this custom area to this chart. Let's say I will draw this India, I'll keep India, Bhutan, Nepal, China in one of the custom area. So I need a mechanism which will map, any user from these countries would come, it will map to a particular shard. Let's say this is the shard 1. Okay, this is the shard for India, China. Maybe I should not talk about India and China. India itself and China itself has a lot of population. So I may go for, maybe only for metro cities. I have maybe this Delhi and um, what else? UP, not metro, I'm just keeping this. Delhi, UP, maybe Punjab. Okay, and anything, let it be this Delhi. For Delhi, UP and Punjab, I have taken a custom shape. The shape can be anything, and I have mapped down the thing in this shard. So any user who will register from this any of the location, Delhi or UP or Punjab, will the data will be stored in this shard. Okay, so maybe here I have another shard for I am in Odisha, so I'll just put Odisha here. Maybe Chhattisgarh. Okay, maybe West Bengal. Okay, so nearby places. So any user would be registering from this either Odisha or Chhattisgarh or West Bengal. That data will be stored in this shard, which is dedicated for that shape. So there should be someone who would map that custom area to this shard. Okay, there should be a mapping service. We can say that we can call it as some locator service or something. Okay, locator service. So that is what we are doing here. Driver location is being updated to the DB. So a single DB cannot hold actually so much of data. Okay, 50k requests per second. We are assuming that database can go for let's assuming a 5k request per second. The immediate solution would be, okay, let's bring 10 databases. Each database will take 5k request. So our problem is solved. But if you are taking 10 databases, you are also have to pay more money, right? That is not a solution. Solution is sharding here. We'll shard it, will partition, not exactly partition, we should call it as shard. So we'll shard it on some basis. Okay, maybe this custom area, but this custom area is not optimal solution, guys. Uber actually follows another way, another solution. Uber actually uses its own what is that called as, some custom area, like predefined custom area actually, and that is h3 sharding. Okay, h3 sharding, this is normally custom area sharding, and Uber uses this h3 sharding. What is this h3 sharding? Let me just tell you that. Okay, so yeah, so we have covered this riders thing, drivers data. We have covered this the number of drive requests, or you can say call it as a throughput. We are talking about right now the storing the locations. Okay, we are storing the location right now. And what else I have left out for this? Yep, yeah. So Uber, we are talking about h3 here. So Uber uses this S3 library, you can say, geospatial library, you can say here, guys, S3. So what exactly this S3 does? S3 says, okay, instead of taking randomly any custom area, it says that the shapes, all the shapes would be, what is that, a hexagonal. Okay, where is hexagon? Yes, this is hexagon, right? Yes. So instead of taking any random shapes, we'll go with hexagon. It will take lot of hexagons. Okay, it will take lot of hexagons, and the benefit of taking hexagons is actually hexagons actually completes the sphere very well. You can think of a football. Okay, there are spheres, hexagons, right? There are hexagons, and through that hexagons, it is covering entirely that sphere. Our world, Earth, is a sphere, so we can think of hexagons covering, okay, all the entire covering entire sphere. So we are mapping the spheres, so these hexagons to each of the shards here. So there is no Delhi, UP, Punjab, no custom area here, but rather we are going with this hexagons. Okay, hexagon 1, we'll say this is, let's say, hexagon 1, h1, hexagon 1. This would be hexagon 2, this one would be hexagon 2. Okay, and these are hexagon 3, let's say. Don't get confused with h3 and h3 here. h3 is the geospatial library of Uber, and this is the serial numbers I am writing here. there are, let's say there are 5 hexagons which is covering entire globe, which is not really possible, but let's assume it. So there would be 5 different shards. Data from user if comes from any of these hexagons, so this mapping service, locator service, will map down this shard and will keep that respective data in the respective shard. That is how it would work. Okay, so now if I talk about, if we include this solution here, so this db, there cannot be a single db actually. Okay, there cannot be a single db. Also, this db would be sharded, so I'll just say this is sharded db. Okay, yeah, that is what, because you have segregated it different, but different area wise. Okay, and there, and how this would be done, how actually it is managed, something would come up in between them. You can say that it is a load balancer. Yeah, there would be a load balancer here. Now you can say that db has more number of instances. Okay, this sharded db means there are a lot of instances of db, but why we are calling it sharded db is it's not actually instance of the same db. Each instance or each shard of db is referring to a different location of the world. Okay, so there would be this locator service which will also act as the load balancer, guys. Okay, I'll just name it load balancer. So locator service. Also, see, there will be number of instances of this locator service, so it's better if we copy one more there. Maybe I don't need this. Just keep it here. Okay. Yeah. Fine. Arrange into back. Yeah. So this is how. So there is a instance, a lot of instance of locator service. So it would balance, like it would map the major task of the locator service is to map actually. Okay, map whatever location, whatever position it would fetch from the driver. So driver is updating, giving the data of its position to this driver location service. It is passing the data to locator service. Locator, what locator service will do, it will map. Okay, the map, the location fetched by the location of the driver fetched. Okay, right, and it would map it to the particular shard of the db, and it will send to the particular db there. I have written here only one actually. You can think of this 2 3 shard which we have created earlier. Okay, right, you can think of this. Fine. I hope you are understanding this, whatever I'm doing, guys. And you just can think this is, this shard can actually communicate on this. Uh, okay, like all the, it has connection to all this stuff, all the shards. Okay, fine. Understood how it is managed. So many requests. Now we are actually able to handle, even if at peak 50K requests are done. So basically we are actually sharded the db, and this locator service is there which is actually mapping down the like what, from what hexagon the request has come, and it will map down and it will write to the particular db, shard of db. So I can just call it as shard 1. Okay, this is shard 2. So it will either go to shard 1 or shard 2 or shard 3 or shard 4, right, right. And we can expect that, we don't expect every time we would be writing the request or writing the data in the same shard. No, might not happen. I might get some data from Delhi, next moment I may fetch the driver location from Chennai. Okay, so likewise. So now this way the entire requests are actually distributed properly and handled properly. Is it clear, guys? Could I make you understand this driver side thing? Yeah, we cannot go to the user rider side thing. But yeah, this it would be, I can say this would be a part of the entire system design of the Uber. Okay, we have sorted the driver location part. Okay, I had planned for this, what is that, rider and all, but yeah, it's fine. We can stop here. We can stop here. We are good with the driver location service, right? Fine. Is it clear to everyone, guys? It's already 9:30. I've taken half an hour more. Like it's two and a half an hour. So I think most of your uh, you need a load balance. I think, I guess now. Okay. So up to this, is everything clear? Is everything clear, guys? I hope you are getting the that essence of system design. Actually, system design is not about coding or something. It's all about the pre-development phase. You have to decide. See, now what we decided here, we decided actually, okay, so these many we priorly we figured out, okay, these many requests should be there, so we need a locator service load balancer there, which would actually map this thing. We need that driver location service. We need to actually shard these dvs. Okay, if you go directly to the development phase, you might not think about this. Okay, we have to understand, yes, we have to shard it. So yeah, how many shards was discussed? 20 shards we had to do during system design phase. During system design phase, we had discussed that, okay, we need 20 shard. So while developing, we'll create 20 shard. In the cloud we would take up 20 shards or something. Okay, right? Okay, so that's how it goes. So this is very important before you develop actually a product or service, guys. Okay, also what kind of database you will take. Here we are dealing with this geolocations, the position, the longitude, latitudes and all. What kind of database actually supports this? Not every database will support this longitude, latitude, these positions. Basically you would go with either the Postgre has supports it. MongoDB is also supported. Okay, Postgre supports it. MongoDB supports it. Based on other conditions, you would either go with Postgre if you want this SQL based thing. Okay, even I guess Postgre also support NoSQL, but anyway, you can go with either Postgre. Postgre normally goes for relational actually, and MongoDB has this no non-relational thing. You'll go with any one of them on the condition. It may happen that your interviewer says no, we don't go with this uh, MongoDB or Postgre. We don't use that. So there are other solution also. Okay, so that actually what your company policy is, what they are thinking, what is the business logic, how they are actually planning to take it ahead. They would say, no, no, we don't want to use Postgre, we don't want to use MongoDB, give us another solution. So you will go with another solution, other solution. There are other solution also which will behave in a similar manner. Okay, right? So yeah, that's it. You can if you want to know more, you can also go for this. There are many things. There is CQRS approach and all other things. If you don't want to use Postgre and MongoDB, you will go with CQRS approach. That will also help you in storing this, indexing the locations and position and all. That's it, guys. I'm not like extending this session anymore. It's already so much. Okay, it's like we have taken this 2.5 hour session. So that's it for today. So I'll not take up your time much. Okay, so I hope you enjoyed this session, everyone, and I hope all of you taken something out of this system design course, day 1 and day 2. So we did this this is new also for us, because we are doing this for the first time. System design course, we are giving it for the first time. We thought of, let's give it to our student. It is also an important part of interview process and recruitment process. That's what we came up with, and I hope I have justified your time. Okay, my time, your time, everyone's time. That's what I would hope. Okay, guys, so I hope everyone is good with the assignment question. So even I forgot now what was the assignment question. Yeah, the question was you have to give the you have to write down what was the casing strategies. Okay, like the cache aside, read through, write through, and write behind. Okay, right. And yeah, you have to submit this one, guys, this driver location thing, whatever we have done. Okay, anyway, this material you will be getting, but do it from your own side. Maybe you can take some different numbers. Okay, don't take 1 million drivers, you may take 50 million drivers, and you can work it out. You have to submit this thing. Okay, this one. Okay, create it, design it in a document or something, and you submit it. Okay, this would be a project submission. This would be a project submission, and the assignment would be yeah, this no, this I had actually, yeah, this you can say examples of message queue and pub sub queue. What are those exactly? And the examples of message queue and pub sub queue. You can I have just written it down here. You can just ignore this rabbit and queue. I might not be correct. Okay, don't remember exactly, but I think that is correct. Pub sub queue, Kafka is example of pub sub, and RabbitMQ example of message queue. Anyway, you research about it, what it does, and what are the examples of this message queue and pub sub queue. This was an assignment. Second assignment was yeah, this one. You have to define all these four casing strategies. These two are assignment, and project you will submit by taking some different throughput. Okay, this whatever I have discussed, guys, this is actually the throughput I was discussing. Throughput is the number of requests your system can handle per second. So that's what you submit this three thing for today. So yep, I'm done with the session. I hope you enjoyed this session, guys. I'll not take any more time. Bye bye. Take care. Good night, everyone. I will have another session, but not on the system design. That would be a placement and career session, guys. Okay, do catch up. I think that's tomorrow, Monday. You'll have your career and placement session. That is also an important session where you will be guided. How should you prefer, like, go for an interview? How should you prepare for interviews and all? That's very important. Attend also that session. Okay, all the details will be sent to you over community. It will be posted. Also, you will be getting mail about it. Okay, so let's meet there in the career and placement session tomorrow, guys. So thank you, guys. Thank you, and thank you for joining. Thank you for attending the session. Bye bye. Take care. Good night. Happy learning. Keep learning. Keep rocking. That's what I'll say. Okay, fine.